Welcome everybody. I am thrilled to have you here with me watching this recording. I want to welcome you to our classic JavaScript, the hard parts workshop. And tonight we are going to be focused on callbacks and higher order functions in JavaScript. Now I'm going to be doing some fun diagramming throughout this, so I hope you look forward to that. But my name is Jaime. I am the lead engineering instructor of the part-time remote immersive program here at Codesmith. And I just want to say before we kind of dive in that this is one of our more, I would say, intermediate workshops. You know, if you are brand new to JavaScript, no worries at all, by the way. You might find some of the code, some of the examples a little bit daunting, perhaps challenging, but no pressure either way. You're more than welcome to be watching this recording. If anything, I hope it gives you some great context for what is to come and what is ahead of you. So let's get started. We'd love to hear input from our community, so if you would like, please feel to share any takeaways that you might have from watching this on your social media with hashtag Codesmith. Always enjoy that. But before we get into the weeds, let's actually talk about what Codesmith is. Well, our mission at Codesmith is to create irreplaceable engineers and technologists in an ever-changing world. Codesmith is based on an immersive engineering program that aims to develop grads who are autonomous and flexible engineers and problem solvers that can really handle any sort of issue or problem or technology that is thrown at them. We really pride ourselves on helping to make sure that tech has more people taking a lead who actually mirror society as a whole. We're very big on inclusivity. We want folks who understand the problems that need to be solved in our current world and have the problem-solving capacities necessary in order to enact real change in the world around us. And our approach and mission does create strong outcomes for our grads. This slide goes over some of our statistics. So these SIR numbers are weighted averages of the part-time program and the full-time program combined. You can find information about recent job offers, this kind of stuff, on our outcomes report that is pinned on our website. So feel free to take a look at that. So our immersive program has two different campuses. Effectively, one program is full-time and one program that is part-time. The full-time remote immersive program is about 14 weeks long, about 3 months. And the part-time remote immersive program is about 41 weeks long. This is a little over 9 months. The hours here are listed for reference, and you can find upcoming start dates for these programs on our website at codesmith.io or become-irreplaceable.dev. Now, when you are deciding, which program is the best fit for you, just know that both of these programs are totally open to all and have the exact same curriculum and admissions process. The only difference between these two programs, between the full-time and the part-time, are the pacing and the length. So you're just going to have to choose the program that works best for your timeline, your goals, your schedule, your overall lifestyle, and so on and so forth. You can't go wrong with either. It just depends on whatever you feel is best for you. So in either of the immersive programs, the academic team at Codesmith, of which yours truly is a part, will lead your core lectures, will help you review your material, will help drive your learning and overall growth throughout your time in the program. And the team here is really committed to our residents' success. We commit time to each student and follow their journey to help them be as successful as possible through a very difficult thing to do, of course. So here's an overview of our admissions process. So it's going to start with an online application. You're basically just going to write a short essay about your passion, about your experience with programming. Next, you will have a non-technical interview. And this interview is going to be non-technical, behavioral, really just meant as a conversation to help us get to know each other. This is going to be more or less a 30-minute conversation with a member of our admission team. And this is a great time to ask questions, get a personalized study plan, figure out what your priorities are. It's just to get a better sense of who you are and what interests you about programming and problem solving. After that, you'll move on to a technical interview, kind of stage and era, where you're going to work through JavaScript challenges with one of our technical interview fellows. So in these interviews, we're really going to be assessing your communication, your problem-solving abilities, your overall foundational JavaScript knowledge, and callbacks and higher order functions are definitely an aspect of this. And the technical interview is a great way for us to assess just where you're at from a technical perspective. After this, we will arrive at a decision, of course, and a member of our team is going to call you to go over just feedback, next steps, all that good stuff. And if you are accepted, you will move on to talking about logistics for finalizing your spot in whatever cohort you please. So at Codesmith, we offer a wide array of free learning resources. I think this is some of the best value that Codesmith has to offer. And this caters to everyone depending on where you are in your coding journey and preparation process. We provide support for those at any entry point. If you are just getting started out, I personally recommend downloading our syllabus, signing up for our newsletter on our website as well. You can check out CSX, which is our free online learning platform. This is particularly how I learned JavaScript for the first time. It is a fantastic platform that I couldn't recommend enough. To pair with that, I would really recommend that you join our CSX Slack community. Some really amazing folks in there, a great way to meet other people who are trying to level up, who are trying to learn JavaScript, who are trying to learn coding and problem solving. It is just a great place to confer and to meet other people who are at various points in their Codesmith journey. We have a lot of alumni in there as well. After that, I'd recommend joining one of our free events. We have tons for different levels of coding knowledge. We have intro to coding workshops, beginner study group events. We have our JavaScript, the hard parts workshops, of course. And this is a recording of one of those workshops. And if you are at any point in the process, of applying, of wanting to get into the program, definitely feel free to schedule a call with us at any time. You can schedule a call with a grad. Our team will pair you with someone who has a similar background to you. Or you can talk to someone on our admissions team, and you can find this information on our website. We are here to help you out, of course. So we have a couple of prep programs. So if you're the kind of person like me who tends to learn best with a little bit more structure and accountability, I would highly recommend either of these prep programs. I did both, JavaScript for beginners and CS prep. I came into this line of work from a fairly non-technical background, so I felt like it was necessary for me to kind of just do the full slate of what was offered. I did these both, and I loved both of them, CS prep in particular as well. JavaScript for beginners is really designed as your very first step into web development. CS prep is going to build on that foundation. And CS prep is actually kind of going to be focused on helping you pass our technical interview to make sure that you are prepared to do as best as you can during our actual immersive program. We have a ton of different scholarships and opportunities available. So if you're interested in applying, do just let us know that you're interested in that, and we'll make sure to get you the proper application for that particular scholarship or opportunity. You can find upcoming start dates on our website, again, codesmith.io or become-irreplaceable.dev. So meet our wonderful admissions team. Amanda is fantastic. She is our admissions manager. Best way to get in touch with her is through the CSX Slack, but do let me know at any point if you'd like to be connected directly as well, and I'd be happy to facilitate that. Anyway, y'all, that is all for housekeeping. Let's actually get into the workshop. So this evening, my friends, we're going to be talking about callbacks and higher order functions. Now, in our JavaScript, the hard parts workshop, we really start with this set of fundamental mental models that we'll go over on the next slide. But just to intro this here, callbacks is really one of the most misunderstood concepts in JavaScript. It is specifically because of callbacks and higher order functions that we, with built-in JavaScript, are able to leverage functions and methods like map, or filter, or reduce, these methods that we all know and love that help us be more productive in our day-to-day. Callbacks also make our code more declarative and readable. And callbacks also form the just general backbone of our Codesmith technical interview, and certainly form the foundation of so many concepts that you will absolutely encounter in actual technical interviews for many different positions in the real world. So before we dive into any sort of diagramming, let's start with kind of these classic first principles. These will be our guiding light as we move through diagramming and understanding what is actually going on a code level, line by line. So we will diagram each line of code that you're seeing here on the next slide, so worry not, my friends. Let's talk about functions. What is a function? Well, a function is really just an algorithm. It is a set of instructions, and these instructions are basically, we can package these instructions and we can save them in a definition. So we define a function with a function definition, and we can then invoke this function later on using a certain syntax where we basically write the function's name, right, with parentheses afterwards. So here on this line, we are defining our multiply by 2 function, and here we are calling or invoking our multiply by 2 function. So these are two different uses of the multiply by 2 function. The first here is again to define it, and the second here and the third here is actually to invoke or execute or run it. So this is what a function is. Now in JavaScript, we have this concept of the thread of execution, and the thread of execution is basically this entity that is really interpreting and reading and executing our code line by line. The way, that JavaScript works is that it goes through the code line by line and does whatever the line of code says to do. Pretty simple at a high level. Now, the last kind of first principle that we're going to incorporate rather in our understanding of the code and diagramming is this concept of memory. We have global memory, which is a memory that the entire program is leveraging, and we might have local memory that is going to be attached to any particular function or block scope in our code. And all memory is just a store of data. And this store of data maintains this concept of a variable environment. So in JavaScript, we can basically store information, we can store some data in variables that we get to name, right? We don't have to call this num, we could call this number or numero or integer or whatever we want, really. But the whole point is that this is a variable that has a label that we decide, and we can then tell JavaScript to store this information to be recalled later. So we're going to explore two different types of memory, global memory and local memory, and we'll see this as we actually diagram this very example right here. So my friends, let's actually talk about this. Let us diagram this. Let's take this line by line and see exactly what is going on in this code here. So just to orient you all in terms of the setup that we have our global memory over here. We've got our global execution context, and this is where we're just going to basically handle any sort of logic that is in our code. This is kind of our workspace. You can kind of think of it that way. And then this is going to be, this is a data structure in JavaScript called the call stack. And the call stack is basically going to hold information about the current function or program that is being run in the current execution. So as we invoke functions in our code here, like let's say as a result of this or as a result of this, we are going to push the invocation of that function onto the call stack. We will do whatever that function tells us to do given the input, and afterwards it will get garbage collected, and we will pop that stack frame or that execution context off of the call stack. I'll recap this when we diagram, so don't worry if that went over your head a little bit. Let's dive into the actual code. So me, as the JavaScript interpreter, I am going to go through this code quite literally line by line on an execution, kind of on the execution standpoint. So what is happening here? Well, we are declaring a variable labeled number with the let keyword, and we are assigning it the value of the number 3. So what am I going to do as the JavaScript interpreter here? Well, what I'm going to do is in my global memory, I am going to store a variable called num, and I am going to give it the value, let's try this in a new color here, the value of the number 3. So that's what this line of code was doing, right? We declared a variable with a let keyword num, and we assign it the value of 3. Okay, let's move forward here. What are we doing on this line here? We are declaring a function labeled multiply by 2. And multiply by 2 accepts one single argument, and this argument will be labeled with the parameter input number. Now, I just want to say from an execution standpoint, we, as the JavaScript interpreter, all we care about is that a function was defined. So what I mean by this is that what we're going to do is we are going to store in memory, right, this variable with a label multiply, pardon my writing here, multiply by 2. Now, what multiply by 2 is simply a function definition. So we can notate in our diagramming in this way. All we are saying is that, hey, multiply by 2, I don't really care what the actual underlying definition or code is, but all I'm doing as a JavaScript interpreter is I am taking this function multiplied by 2 and I am storing it in my global memory. And we can do that with this symbol here. This is basically a box with the letter F here, and a function, right, takes in an input and produces an output. Not all the time, but oftentimes. And so this is the way that we would notate this in our diagramming. Again, all we're saying here is that multiply by 2 is a function, and we store that in our global memory. So as the JavaScript interpreter, we actually jump down to the line here because all we're doing here is defining a function. We are not actually invoking the function such that we are running the code within it. We are just defining it and storing its definition in memory. So now on this line, this is where some interesting stuff starts to happen. So I just remembered I forgot to make this another color. My apologies. It's a function. Oh well. So here on this line, what is happening? Well, we're declaring a constant labeled output, and we are assigning output the evaluated result of invoking multiply by 2, passing in num as an argument. Now let's actually unpack what is going on here. So firstly, what we know is, right, we are storing some data in our memory, right? So I am basically declaring, right, a constant or a variable labeled output. And right now, I actually don't know what output is because output has been assigned the evaluated result of doing something. So I need to do that thing before I actually fully determine what output is. So how can I figure out what output is? Well, output is going to be the evaluated result of invoking or running multiply by 2, passing in num. So at this point, JavaScript is going to imagine that as a JavaScript interpreter, I'm thinking, okay, what the hell is multiply by 2? What is that? And as JavaScript, as the interpreter, I'm going to look into my memory to see, have I saved some information at a label called multiply by 2? Oh, I have. Multiply by 2 has been stored in my memory, and what multiply by 2 is a function. I know this as well from the fact that there are parentheses, right? This is a function invocation. Okay, so I know that multiply by 2 is this function that I've stored in memory. It's this right here. Okay, num. Damn, what is num? Okay, I need to look in my memory, right? Oh, yes, that's correct. Num, I did store in memory. Num is a variable that has the value of the number 3. That is how I've saved num in my memory. Okay, so now I know that I'm invoking multiply by 2, passing in num. So three main things at a high level are going to happen when you invoke a function in JavaScript. Let's kind of walk through what those things are. Well, the very first thing that's going to happen, I would say, is that we are going to push multiply by 2, passing in num. We're going to push that execution context onto the call stack in the form of a stack frame. So onto the stack, I will push multiply. You know what? Sorry, I'm going to abbreviate this just because I have limited space here. We're going to push multiply by 2, passing in num, right, which is 3, onto the call stack. So because I'm invoking this function, right, with an argument, I am pushing that execution or that function call onto the call stack, because the call stack is a structure that keeps track of the functions that are currently running in our program. So that is the first thing that happens. The second thing that's going to happen is that we are going to weave our thread of execution into the context of the function. We can start it here and we'll move it to this line and then this line. So just know that we've moved from the global execution context, right? We've moved from this space here into a more localized, more specific execution context. So the third thing that's going to happen is we are basically going to open up a new local execution context right here. And this is going to live kind of in our global execution, because this function call is happening as a result of the global kind of function that's running, or just the program, right? This whole thing is kind of a function or a program that's running. And so we have our global kind of frame on the call stack. Okay, so our local execution context is going to look very similar to our global one. You can this is kind of like inception here, where we basically are going to have Thank you for waiting. We're going to have a local execution context, LEC, and I'm sorry, my apologies. We're going to have our local memory here, and we are going to have our local execution context, right? I'm just going off of these here. We have our local execution context and our local memory. And up here, we have our global execution context and memory, right? So in our kind of more localized context, this was the third thing that happened, right? So just to recap that, we pushed multiply by 2 onto the call stack, passing in that argument. We weaved the thread of execution from where we left off into what it's actually telling us to do, this function, invoke that function right here. So we're going to walk through that code. And thirdly, we opened up a new local execution context with its own local memory. So the first thing that we do in JavaScript when we invoke a new function, right? Or sorry, after those three kind of foundational things I talked about. So now we're actually in the execution context of the function itself. The first thing that we want to do is pair our arguments with our parameters because we want to store this information in memory as well. So what we're going to do is basically we are going to store a variable, right, called input number. Now, where is input number coming from? Right, that is the name of the actual parameter that's going to hold the argument that was passed in. So we pair our parameters with our arguments. How do we know what the argument is? We have to look at where we left off. We invoked multiply by 2, passing in num. And as JavaScript, we looked in our memory to say, oh yeah, num, that's 3. So it would stand to reason that I am invoking multiply by 2, passing in 3 as the input number. So the argument of 3, the argument of 3 gets paired with our parameter input number because, right, we had invoked multiply by 2, passing in num. Input number is basically just a label or a placeholder, right? It's a placeholder for some future information that's going to be coming in through a function call or an invocation. So we paired our only parameter with our argument, right? We paired the parameter input number with the argument of 3 because we had invoked multiply by num passing in 3. Okay, so now that we've done that, we can actually move our thread of execution into the first line of code in our function. So what is this code telling us to do? Well, I declare a constant labeled result, and I'm going to assign it the value of input number, whatever the hell that is, multiplied by 2. Let's unpack this. So I need to store in my local memory, right? And I'm in local memory because I'm in my local execution context. We're going to now store this information called result, right? A variable or a constant called result. And what result is going to be, you know what? I'll take this even further. I don't know what result is yet because I'm waiting for the result of a particular operation. So let's actually unpack what is going on here. Input number, what is that? Oh yeah, input number, right. I need to look in my local memory, right? I look in my local memory to see, oh yeah, I did store some information at this label of input number. So I know that input number is 3. Cool. I now know that I have to multiply input number by something, and what is that something? It is the literal number 2. So 3 times 2, as we hopefully know, is 6. So now, after doing this computation, right, it took like a second, but it was a computation that I had to do. So I deduced, right, that 3 times 2 is 6, and now I know that result is going to be 6, right, the result of that operation. So I now know that result is the number 6. Fantastic. Cool. Okay, so I can remove this because that is work that has basically been done. And as the JavaScript thread of execution, I move on to the next line. And now we are at a really interesting point because we have hit a very special keyword in JavaScript, the return keyword. Now, the first thing that we want to know or understand about the return keyword is that the return keyword is what the output of the function actually is. The return is what multiply by 2 returns when invoked with any particular input number. So I can see that we are returning result. Now, what are we returning this to? Let's try and remember how did we even get here? Why are we doing this to begin with? We entered this whole function and did these 2 lines of code because we needed to evaluate what multiply by 2 passing in num is. So whatever is returned by the function, given that input, that is what this is actually going to become. So let's establish here that by returning result, what we're doing is we are saying that, hey, result is what this evaluates to, right? Because that is what multiply by 2 returns. So I can now say without a shadow of a doubt that output, right? I was trying to figure out what output was that whole time. And I had to do all that work, right? All this diagramming to figure out that output is going to be what result is. So now I know that output is actually 6, right? Cool. I now know that output is 6. Now let's actually talk about what happens with what additionally happens with the return keyword. Remember those 3 steps that I mentioned to get us to this point, right? When we invoke a function, three main things happen. Let's just think that we need to do the reverse of those 3 things. So as a result of returning or reaching the end of the function, right, we do 3 things. The first thing that we want to do is we want to pop this function execution or this stack frame off of the call stack, right? We're done running the function, so we now pop it off of the call stack. So we pop multiply by 2 off of the call stack. We're back in the global program. And because of that, right, what's the second thing we need to do? We need to weave the thread of execution back to wherever it is that we left off, right? We left off here. It was this line that forced us to do all of this work of working through this line by line, and we left off here. We finally evaluated what this is, right? This is just the number 6 based on our computation, based on running the function as intended. And so now we just weaved our thread of execution back out into the global context. And the last thing that happens is that JavaScript makes this execution context what is called eligible for garbage collection. That is quite literally, from a computer programming standpoint, what is going on. There is this concept of a garbage collector. We won't really dive into that right now, but a garbage collector is responsible for basically cleaning up the context of functions of sub-programs that run in our program. So this execution context, we're done with it, right? We don't need to do anything with this anymore. So this all becomes eligible for garbage collection. Imagine that I actually just erased this. For convenience sake, I'm going to keep this kind of here because I'm going to be basically whipping up a new execution context. And quite frankly, I'm a little bit lazy to redraw it. So forgive me. Just imagine, right, that all of this actually went away for a little bit, that I actually erased all of this stuff here and that we completely lost this execution context, and we'll need to whip up another one whenever that needs to happen. So conveniently for us, that's literally going to happen in the next line. So again, to recap, the 3 things that happened were we popped the function execution off of the call stack, we weaved the thread of execution back out into the global context, and we also made the execution context that we were just in eligible for garbage collection. So it is basically wiped from memory. Imagine that this was all happening in memory. We needed to do some stuff there, and that all gets wiped from our memory. Okay, so now as JavaScript, right, we read line by line. So we finish this line of code finally, and we get to the next line. Okay, what is this line telling us to do? I'm going to need to move around a couple of things here. Okay, so what is this line telling us to do? Well, we're going to declare a constant labeled new output, and new output is going to be the evaluated result of invoking multiply by 2, passing in 10, the literal number 10. So in memory, right, I'm the JavaScript interpreter. I now declare this constant, right, called new output. And new output, like before, I don't know what that is just yet, because what do I have to do? I have to invoke multiply by 2, passing in an argument. And in this case, it's the number 10. So we invoked a function. We need to do 3 things, right? So first thing we need to do, I'll go a little bit faster this time. We need to push multiply by 2, passing in 10 onto the call stack. Okay, that's the first thing we had to do. Second thing is we want to weave our thread of execution into the function context. So we're finally at the function, right? Okay, the last thing that happens is we create or introduce a new local execution context attached to its own local memory. So imagine for a second that I actually drew this up again from scratch, but we introduce or push and enter a new execution context, which is a local execution context. So cool, we did our three classic things when we invoke a function. And now what do we need to do? We need to pair our parameter with our argument, or our parameters with our arguments. So our parameter, right, is input number. And now in this new kind of context, what is input number? Well, I know as a result of this line that I invoked multiply by 2 passing in 10. I didn't pass in the value of a variable. I quite literally invoked multiply by 2 passing in the actual number 10. So input number is going to be paired with that argument of 10. So it stands to reason that input number is 10. Okay, I've paired my arguments with my parameters. Let's move our code forward here. So I declare a constant labeled result. So I need to store this in my local memory. And pardon my writing, y'all. Result is going to be what again? Okay, well, I need to actually compute this. It's going to be input number times 2. Okay, input number, I know from my memory, is 10. Cool, so 10 times 2 is 20. And now I know, right, that result must therefore be 20. Okay, fantastic. So result is now 20. Let's move on to the next line. Oh, I need to return result. So as we discussed before, right, the return is what delivers the output of the function back out to the global context, or whatever it is that this function was called. And so what did we do to get here? We invoked multiply by 2 passing in 10. So now I know that multiply by 2 passing in 10 is going to evaluate to whatever is returned from the function given the input of 10. So I now know, right, that new output is actually going to be 20 because 20 was returned out of our function. So new output is now 20. Great. Okay, I should have just dragged that, but you get the point, y'all, right? If we imagine that result basically became the new output over here. Okay, 3 things that happen when we hit a return keyword and we end a function, right? The reverse of the 3 things that put us here. Well, we need to pop multiply by 2 off of the call stack because we're done with that. We're done with that function. Next thing we got to do is we have to weave the thread of execution back out to where we left off. And the third thing we need to do is we need to basically make this execution context eligible for garbage collection. And now for real, I am the garbage collector, garbage collecting my execution context from memory. Cool. And so we move on, right? Because we're JavaScript and we move line by line. Oh, would you look at that? There are no more lines of code. We are basically done, right, with our program and scene. Hopefully this was a solid demonstration of how this is all actually working under the hood and what is going on when we actually define and invoke a function in JavaScript, right? So what was the result of doing all this? Well, we stored num in memory, we stored multiply by 2 in memory, we stored output, and we stored new output in memory. And we needed to do some work, right, to evaluate what those things actually are. Anyway, y'all, let's take a detour before we talk about, or not a detour, let's just continue on before we go into our next diagramming example. Let's talk about functional programming and just some essential features of it. So functional programming is basically comprised of a combination of pure functions and higher order functions. Now, when we say pure functions, what we're really referring to is a function that does not have a side effect. And what I mean by that even further is that a pure function only does one thing. It takes in an input or inputs and it returns an output. And a pure function does not change anything outside of itself. It does not update the state of anything outside of anything that is not in its scope. A pure function is also a function that, given the same input, will always return a corresponding output. We need a pure function to be predictable, which is to say that if you invoke a pure function with a particular input, you can invoke it with the same input a million times, and it should produce the same exact output every single time. If not, that means there's an element of randomness or something else is going on, in which case this would disqualify it from being a pure function. When I said a pure function doesn't alter anything outside of its state, imagine in our global context, right, if we declared a variable called x, and we assigned x the value of like 3. If we have a function later on that actually increments the value of x, like it accesses x in its function somewhere in its function code and increments it by 1, that function would not be a pure function because it is altering something that exists outside of its scope. So hopefully that's clear. But otherwise, another kind of function in functional programming is a higher order function. And these are what really are the basis for these great tools like filter or map or reduce. They also help us write more readable code. And they're a part of our interview and are the foundation for many and almost all technical interviews that you will come across as you apply for roles. So let's take it back a little bit, to be honest. Why do we even have functions? Like, what is the point of actually having a function? Let's examine why we might want to have a function or write a function. So imagine with me, right? We are creating a function called 10 squared. And imagine the 10 squared doesn't take an input and it returns 10 times 10. These are the requirements of our 10 squared function. So what is the exact code that we're going to write in JavaScript to make this happen? Well, it's thankfully pretty simple. We declare a function called 10 squared, right? 10 squared does not take in any arguments, right? So we don't label any parameters because it doesn't accept any arguments. And what does 10 squared do? It quite literally returns whatever 10 times 10 evaluates to. This is an expression, right, in JavaScript that's going to evaluate to something. And hopefully we know that 10 times 10 is 100. So stands to reason, right, that 10 squared will just always return 100 no matter what. We can invoke 10 squared 1,000,000 times, 1,200,034 times, and we will get 100 every single time. So if we invoke 10 squared, we should, if we were to console log this, right, we should see in the console 100 because that is the evaluated result of invoking 10 squared. Now, okay, I just created 10 squared. Now I want to create a function called 9 squared. Okay, 9 squared also doesn't take in an input, and it returns 9 times 9 now. It doesn't return 10 times 10, it returns 9 times 9. So how would we write this new function that we're now tasked with writing? Much like before, we declare a function, right? 9 squared doesn't take in any arguments because it doesn't take any arguments. It takes no input, which we know. So no parameters to label. And what does 9 squared do? It returns quite literally 9 times 9, which is 81. So if I were to console log the evaluated result of 9 squared, what should I expect to see? The number 81, right? Okay. Hopefully this is starting to get a little bit suspicious. Okay, damn, what if I want to create a function for 8 squared? Okay, so I declare a function labeled 8 squared, doesn't take in any arguments or input, right? So I don't have any parameters, and this returns 8 times 8. And so anytime I invoke 8 squared, it's going to log 64. Now, we do have a problem here. We have something that is not ideal. And if you couldn't already tell, we are breaking a principle. We are breaking something called the dry principle, which stands for don't repeat, pardon my horrible language, repeat yourself. We are being repetitive. We are being ultra repetitive because we are basically writing these individual, to be honest with you, pretty useless functions that literally just return one single thing and can't return anything else dynamically. We just wrote functions for 10 squared, 9 squared, and 8 squared. Imagine if I spent all my time writing functions for the squares of every single number, right? I got to write a function for 64 squared or 65 squared or 68 squared or whatever it is. There is a clear path to an alternative solution here. And what we can do in response to this is we can generalize our function. We can make it more dynamic. And we do this with this concept of parameters. A parameter is quite literally just a placeholder for some future information. It allows us to not have to decide what data to run our particular function or functionality on until we actually invoke it and provide it with an argument, right? The argument is what the parameter is basically placeholding for. So how can we refactor, right, these functions that we were writing earlier? We could simply write a function called square num, and square num will leverage the use of a parameter called num. So what we can do is we can design our square num function such that we can just return whatever num is multiplied by itself. And this can be dynamically decided, or rather dynamically determined, and we don't have to decide what num is until we actually invoke the function, as in these three examples here. So, like before, although much easier this time, I can just invoke square num 3 different times with a different input to return to me, right, to produce the actual result of that base number squared. So I know that square num passing in 10 will result in 100, square num passing in 9 will result in 81, and square num passing in 8 will result in 64. Now, we're going to take this to the next level, because higher order functions quite literally follow this same exact principle. We can take this even further and say and demonstrate that we might not actually want to decide not only what the value is, but what some actual additional functionality is until we run the higher order function. We'll see an example of this in just a second. So imagine that we have a function called copy array and multiply by 2. So we're going to diagram this whole thing out, obviously a bit of a step from what we previously examined, but let's diagram this out, let's talk about it, let's clarify and demystify everything that you see. So we've got our similar setup to before, and let's walk through this, my friends. So just like before, we have our global memory, we've got our global execution context, and we have our call stack set up just like before. And as the JavaScript interpreter, we are, of course, going to be going over our code line by line. So let's start, y'all. We declare a function labeled copy array and multiply by 2. We define this function, and what do we do as the JavaScript interpreter? We just save that function definition in memory. I don't even care what this code actually does. All I need to do right now is I need to just save this, right? Copy array, I'm just going to abbreviate this for obvious reasons, and multiply by 2. And this is going to be a function definition, right? Cool. I'm going to make this a little bit smaller because I need to be economical with, oh my goodness, I'm going to need to be economical with my space here. Let's put that there. Okay, great. So I just declared a function, right? Copy array and multiply by 2. We say that in our global memory. As JavaScript, right, I jumped straight down to here because all we were doing in these brackets is we were defining a function. I did not call it, I did not invoke it. There is nothing that told me to actually run any of this code here. So I go to the next line, the next possible available line. I declare a constant labeled myArray, whose value is an array containing the numbers 1, 2, and 3. So I'm going to create, right, a variable called myArray, or a constant, and myArray is going to be the array containing the numbers 1, 2, and 3. Great. Okay, so I move on. I'm now going to declare a constant labeled result. Okay, and I can see that result is going to be the evaluated result of invoking copy array and multiply by 2, passing in my array as an argument. So I don't know exactly what result is just yet. I'm going to need to do some work, right, to determine what this function call with a particular argument is going to return, what it's going to evaluate to, right? So just like before, we invoked a function, which means that 3 things happen. The first thing that's going to happen is we push copy array and multiply by 2, passing in, my array, I'll just do that. We push that onto the call stack. The second thing that happens is we weave our thread of execution from here, where we left off, into our actual function definition, because we're now invoking the function and therefore calling it and therefore running it, right? Okay. The third thing that's going to happen, right, is I need to whip up, or I need to create, introduce a new execution context enters the fold, our local execution context that has its own local memory, right? So put this here. Cool. Great. We're going to give our local context its own memory, right? And yeah, and it's an execution context. Sorry, let me just move this a little bit here. Cool. So we have our local memory, right? And we have our local execution context. Local memory, local execution context. Great. Okay. So we did our 3 foundational things, right, when we invoke a function. Okay. Now what's next is we need to pair our parameters with our arguments. So we do have a single parameter, right, in the function definition, pardon me, which is array. Where am I getting that? Because array is the name of the placeholder, right? The name of the parameter that's going to hold the argument. Now, what is array going to be paired with? Well, we invoked copy array and multiply by 2 passing in my array, right? And JavaScript is like, what is my array? Oh yeah, it's this array right here, an array containing 1, 2, and 3. So now I know that array in the deeper context that we're in is going to be an array containing 1, 2, and 3. I will say as a side note that this is actually pointing to the same thing in memory. Conversation for another time, but just know that this isn't a copy of this. This is quite literally this in memory. Anyway, so we paired our parameters with our arguments. We're all done with that. So let's actually hop into the code here. Okay, we declare a constant labeled output. Okay, so I'm declaring output here. And what is output? I can see that output is just a really simple, you know what, y'all? Sorry, I'm going to color code this better. 1, 2, 3. Great. And our output, right, is going to be an empty array. So I'm just going to store this empty array in memory. I'm going to move a couple things down because I know that I'm going to need a little bit of space here. Put this here. Oh my goodness, we lost the O. Cool. Okay, y'all. So we've got our array here as well, right? 1, oh my goodness, I'm just trying to make this better for y'all. 1, 2, 3. Okay. All right, so let's move forward here. We just declared our output, right? We stored this in our local memory. Our trusty vanilla for loop. So we initialize a for loop. And so we initialize a for loop in JavaScript, and we declare a variable I, and this is going to hold our index position. We declare a variable I, and we initialize it to the number 0. So because we're storing this in memory as well, I am actually going to, sorry about that, y'all. I'm actually going to keep track of this, right, in memory. I do want to keep track of this. And what is I? I starts off as the number 0, right? So I'm keeping track of I down here. It is a variable that we actually declared, so I want to keep track of it in memory. So the condition of our for loop, so our for loop will run so long as I is less than the length of our array. In JavaScript, right, arrays have a length property, and the length property tells us how many elements are in that array. How many elements can we see? We see 3 elements, right? So the length of our array is 3. So this is all to say that we will iterate in our for loop so long as I is less than the number 3. If we ever break that condition, if that condition ever becomes false, then we will not iterate with our for loop. And after every iteration, we will increment I by 1. I plus plus is the same as I plus equals 1, right? We're just incrementing I by 1. Okay, so with I as 0, let's go ahead and actually go through our first line of code in the for loop. Actually, we want to ask ourselves the question, is I less than the length of the array? It is, because 0, right, is less than 3, and that's currently what we're at. Okay, so what are we going to do? With JavaScript, like with math, I like to go from the innermost to outermost. So what is the kind of first thing that we need to do? Actually, this is, to be honest, this is the first thing we need to do. We need to evaluate array at index I. So we're using something here called bracket notation, right? And hopefully you are aware of this, that in JavaScript, arrays are 0 index. Now, what do I mean by this? What I mean is that arrays in JavaScript, imagine that if they had slots, if this array has 3 slots that are occupied by the numbers 1, 2, and 3, the element 1 is in the 0th index. The element 2 is in the first index. The element 3 is in the second index, and so on and so forth. Arrays' indexes start at the number 0. So the first element in an array is going to be the array at the 0th index. So just keep that in mind. The length of the array will always be the number of the last index position available plus 1, right? Because arrays are 0 indexed. So we use dot notation here, and we need to figure out what is array at index I. So we need to figure out what the array is at the index of whatever I is right now. I is 0. So I'm looking for the array at the index of 0. So I need to look in my array, and I see here, oh, the array at the index of 0 is the number 1. Okay, so I now know that this evaluates to 1 in this particular iteration. And 1, right, 1 times 2 is what? Is 2. So again, my local execution context is just my workspace, right? It's where I'm able to do all my computational work. Great. So now I know that this expression here, array at I times 2, is actually the number 2. And so what do I do with that? I push into my output array the number 2. So I push the number 2 in my output array. And so my array, my output array, right, now it's a 1-element array. It contains the number 2 that I pushed as a result of doing this whole line of code here. Alrighty, y'all. So we are at the end of our for loop code, right, in our particular iteration. So what we do is we now need to increment I by 1. So we increment I by 1, and I is now 1. And before we hop into this iteration, right, we have to ask ourselves the question, is I less than the length of our array? This is what's going to determine if we continue on with our for loop. I is 1, and 1 is less than the length of the array, which is 3. So I know, okay, that this statement is true, so I keep going. Okay, just like before, right? What do I need to do now? I need to figure out what the array at I is. So I need to figure out what the array at the index of I is. I is now 1, right? So I need to look at my array and you see, okay, what is the element at the index of 1? It is the element 2, the number 2. So I know that the array at index 1 is 2. And so that's 2. So 2 times 2, right? I need to multiply 2 times 2, and this is now 4. So now I know, right, that I need to push into my output array the number 4. So we invoke push on our output array, and we push in the number 4, right? And now output is a 2-element array. Great. I'm going to clean up my computational work here. Fantastic. And now, right, I'm going to increment I by 1. So I now is the number 2. I asked myself the question, is 2 still less than the length of our array? The length of our array is 3, and 2 is less than 3. So we carry on, and we do the same or a very similar thing to before. We now need to evaluate this expression, right? We need to figure out what the array at index I is. What is I? I is the number 2. So the array at index 2 is going to be the number, the element, right? What is the element at the second index position in my array? It is the number 3. So I know now that array at index 2, array bracket 2, right? Array at index 2 is 3. And then I need to calculate 3 times 2, right? Because of this, I need to calculate this expression. 3 times 2, as we know, is the number 6. And so this evaluates to 6, this whole thing in here. And now I need to push, right? I need to push into my output the number 6. So I go here and I push into my output array the number 6. All right, let's carry forward with our for loop, right? We just keep going. That's how this works. First thing we need to do is we need to increment I by 1. So I was 2 and I is now going to be 3. Now I need to check my condition. Is I less than the length of my array. First of all, what is I? Okay, I is 3. What is the length of array? Oh, the length of array is also 3. It's a 3-element array. Is 3 less than 3? No, that is not true. So I no longer meet my condition, right? As a result, I don't do this line here. We now know that because I didn't meet this condition right, we break out of our for loop. We completed our for loop because we got to a point where the breaking condition was met, where we actually did not meet the condition required to continue, right? Okay, so we just finished our for loop, and we now need to return output. Okay, this triggers a fun sequence of events, right? First thing is that we hit the return keyword in JavaScript, so we know now that this is what the output of invoking this function is, right? We left off over here. We did all of that work because I needed to figure out what copy array and multiply by 2, passing in my array, evaluated to. So I now know that result is going to hold whatever is returned by that function call passing in that argument, and I have it right here, right? I know that this is actually what result will be. Fantastic. Let me just put this, oh my goodness, I'll put this here, and I'm going to delete this. Great. Awesome, y'all. We evaluated result. It is the array containing 2, 4, and 6. And so our classic 3 steps, basically backwards, right? We just ended a function. So what we do is we pop copy array and multiply by 2 off of the call stack. Great. Fantastic. We weave the thread of execution back out to where we left off, which is this line here. And this execution context that we were just working in, all of it becomes eligible for garbage collection. We don't have any use for it anymore. So we now go back into our global execution, no questions asked. And as JavaScript, we read line by line, so we continue. Oh my goodness, we actually ended our program. We finished all the code. The result, of course, is that our memory now holds copy array multiplied by 2, which is a function, right? My array, which was an array containing 1, 2, and 3. And then now we have our result array containing the array 2, 4, and 6. And C. Hopefully this was a good diagramming session. We got some nice for loop action there, which is always fun. But how does this apply to what we were talking about before? Let's apply this to the concept now. Imagine that I don't want to copy this array and multiply by 2. I actually want to copy the array, some input array, and I want to divide it by 2. How would I write this function? Okay. Well, we declare a function labeled copy array and divide by 2, right? That is going to take in an array as an argument. If I actually look at the code here, I declare a constant output whose value is an empty array. I'm going to iterate, right? Same as before, so long as I is less than the length of our array, we increment I by 1 with every iteration. And now this is where the key difference happens, right? We're going to push into our output array the array at index I divided by 2, not multiplied by 2, right? Because now we're copying the array and dividing by 2. Okay, and then after all of that, we're going to return the output. We declare my array, that same array with 1, 2, and 3, and result is going to be the evaluated result of copying the array and dividing every element by 2, right? Copy array and divide by 2, passing in my array. You might notice, right, that this looks super similar to this. It's actually the same exact code. It's just this says divide instead of multiply, just a label. And instead of multiplying by 2, we are simply dividing by 2. Okay, wow, we had to write all of that code to do a very similar thing. Okay, hopefully the gears are now starting to turn. What if I wanted to copy any array and add 3 to every element? Okay, if I want to do that, I have to declare a function called copy array and add 3. It takes in an array. I got to declare my output array again, right? I iterate so long as I is less than the length of my array. I increment I by 1. And what I push into my output for that current duration is the result of array at the index of I plus 3, right? Then I return the output when I'm done with all my iterations. My array has been declared as an array containing 1, 2, and 3. Result is going to be the evaluated result of copy array and add 3, passing in my array. Again, right? Oh my goodness. Again, right? All the same stuff as before. The only functional difference is that we're adding 3 now instead of dividing 2. We are breaking a principle just like with the square numbers example. We are breaking the dry principle. Do not repeat yourself because we are getting really, really repetitive. So how can we mitigate this? How can we leverage what we've been talking about conceptually to fix this problem? What we can do, my friends, is we can generalize our function just like before. The difference is that now we can pass in a specific set of instructions. We can pass in another little mini function, right? What is a function but a set of instructions? Pardon me. We can actually pass in another set of instructions, or a set of instructions as another argument into our copy array and manipulate function, right? So I can now generalize and say, hey, this function is just going to copy an array and it's going to do something. It's going to manipulate the original numbers to produce a copy with something else. So we can not only pass in an array as an argument, we can also actually pass in instructions or a function as another argument, right? So all the same stuff here. We declare our output, right, as an empty array. We declare our for loop. And now what do we push into our output? We're going to push in the evaluated result of invoking instructions, whatever that little helper function is, passing in the current element. And after our iterations, we'll return the output. And now we get to write another really simple function. This is our helper function. These are our instructions in this example, right? We can declare a function called multiply by 2. Multiply by 2 is a really simple function. It takes in an input or a number, and it just returns that input or that number multiplied by 2. So I can now declare a constant labeled myArray. I can declare a constant labeled result. And result is going to be the evaluated result of invoking copy array and manipulate, passing in myArray, and then multiply by 2 the function definition as the second argument. So now we can iterate over this array, right? And what are we going to do? We're going to multiply every current element by 2. So if we were to actually, run myArray through copy array manipulate, passing in multiply by 2, what should we expect to see, right? An array containing 2, 4, and 6. We're not going to diagram that, but hopefully you see how that would happen based on our previous diagramming, right? So how is this possible? Isn't it so cool that we can use JavaScript in this way? Well, the reason that this is possible is because functions in JavaScript are what are called first-class objects. And so what this means is that they can coexist with and they can be treated like any other JavaScript object. They can be assigned to variables. They can be assigned as the values of properties of other objects. They can be passed as arguments into functions, as we can see right here, right? Multiply by 2, we're passing in the function definition as an argument into another function called copy array and manipulate, right? And also we can return function definitions as values from functions. This is where this concept of closure comes in, slightly more advanced topic, very much related to this, but we'll save that for another day. Point being, though, we are allowed to do this in JavaScript. And this is what makes JavaScript so cool, is that we can literally pass in functions, function definitions, as arguments to other functions. So in this kind of example that we've been going over, which is our higher order function and which is our callback function? Well, what defines these two things is basically the higher order function is the function that is going to accept another function as an argument. We would call this a callback. So copy and manipulate takes in an array as an argument, and it also takes in a callback function, right? This right here is our callback function. The callback function, it's the inverse. This is the function that gets passed into the higher order function. So function 1 is our higher order function, and function 2 is our callback function. So something that I want to kind of clarify here as well is that higher order is, to be honest, just a semantic term. It's just an adjective to describe the function and kind of its role in this relationship and paradigm. There's nothing inherently like under the hood different about this function when we compare it to this function here. They both take in an input or inputs and they produce an output of some kind. There's nothing inherently different about them. This is more about the role that they play in this concept of higher order functions and callback functions. So again, to recap, a higher order function is the function that accepts another function, its definition, as an argument. A higher order function, in the sense of closure, can also return a function definition. All right, y'all. Hopefully this was informative and this was helpful. So let's kind of recap here and kind of bring everything together. It is because of callbacks and higher order functions that we are able to simplify and generalize our code. It allows us to be less repetitive when we are writing a bunch of different kinds of functions. They are the basis for functions, built-in methods into JavaScript like map or filter or reduce, right? Map is a higher order function or method in JavaScript that accepts a callback function as an argument. Filter does the same, reduce does the same. They all do different things, but they all share this commonality. Callbacks and higher order functions are a foundation of our interview and also just the foundation of many JavaScript and TypeScript technical interviews. It is a very popular concept and topic. And super importantly, and this is for another day, is that callbacks allow us to run asynchronous code. They are a core aspect of asynchronous functionality in JavaScript. They form the basis of promises, of async await syntax. Again, all for another day, but callbacks are a very integral part of this overall architecture and design in JavaScript. So anyway, y'all, thank you all so much for tuning in. I hope you found this helpful. I hope you found this informative. It was great to have you. Please feel free to reach out to me on LinkedIn or the CSX Slack. Again, my name is Jaime. I am the lead engineering instructor for the part-time program. And if you do decide to do the program, I sincerely look forward to meeting you, and I hope to do that soon. Thank you all so much, and have a great day or night wherever you are watching this. Thanks.